Okay, I'm going to go through the wave math part. So this is not too awfully difficult. It does require calculation. Some people may have problems with it. So I'm going to show you kind of a way around it if you don't like dealing with exponents on a calculator. First of all, with wave math, you got something called a wavelength. So you have equal areas or the same area that you're measuring on waves. So this one would actually be considered your peak or your the top of it. You also have a wavelength that may go between your two troughs. That is a wavelength. Your unit for wavelength is going to actually be in meters. So we're talking more like physics. Now, the B is also referred to as a frequency. Basically, it's the amount of time per cycle. So it could be 18 seconds per each cycle on the same part of the wave. So again, you would be kind of measuring this, but if I have a period where it passes a certain point, perhaps per second, that would be 2 wavelengths per second. So that's kind of how the frequency is measured. Other than that, those are pretty much the ones you are going to be calculating. We also have energy. It's basically, if you're getting a whole lot of waves hitting you really fast, that would be a high energy. If you hit one every once in a long while, it would be less energy. Energy would be measured in this case in joules. So I would just say don't worry about the unit if you are ending up with numbers. Just worry about calculating it, getting the correct answer, and you get the correct answer, it will match up with your unit. But again, an energy unit is joules, so if they want to play games with it and give you something like a wavelength, which is the meters, and then you have another answer in joules and you're finding energy, it's going to be in joules. If you have a frequency, that may be in a unit called hertz. Hertz would be Hz. But again, I'm not really sure how you're going to see it on the exam. Now, as far as the calculation, these are your formulas that you're going to be using. Now, the bottom two are more with the honors part. But again, I am not sure what they're doing, so I'm just going to give you all the information. They are actually in the review number 3 and the review number 4. Calculating for this is kind of easy. I'm just going to do it with numbers, but let's say my wavelength is 1.8 times 10 to the negative 17, and they want to know what the frequency is. The calculation is actually rather easy if you are calculating for either of these ones. So let's say I want to find my frequency. I would use this formula. You'll notice we have a C. That is actually a constant. It's 3.0 times 10 to the 8th. That would be meters per second. This one would be meters. Again, you don't really have to worry about the units. You just got to make sure you put them in the correct place and actually calculate it. So if I have this, you'll notice with this formula it looks like this, but I can modify the formula, and it is actually kind of simple. You just got to remember that this one is all going to look the same. So let's say I want to figure out this. My constant is always going to go at the top, and you're going to actually see that in another time, and that would be my wavelength. So all I would have to do is just place these numbers in the correct place. So it'd be looking like this. Now, as far as the calculation, some people get a little intimidated with the calculator. You do have a calculator that I did include, and I will send it to your email today. But let's say we have this calculation here. It should come out looking like this. Now, if you run it through the calculator and it's not matching up, there is another way that we can actually do this. Just going to make sure that this is coming out correct. Doesn't look right. Yeah, this would be divided. So let's say I end up with this when it spits out on the calculator. Well, you can also use these exponents. And if I flip this thing up to the top in order to get this exponent, you're noticing that 17 plus 8 equals 25. So when I flip this up to the top, this guy actually becomes in reality this. And then you can just add your exponents. Again, there's two ways to approach it. Some people just like to do it on the calculator. Now the great part is, let's say I want to change this out, and I'm going to be finding my wavelength. The nice part about this first formula is it's going to look like the same thing, except these guys are going to trade places. So if I'm going to pop these numbers in the same way, you're going to notice it's the same exact answer, and it'll be coming out for wavelength. Again, just dealing with those factors. Now let's go to the next one. Now remember, we do have our C, which is a constant. And that's, again, speed of light. Let's go ahead and go to the one with this, which is my energy. So this is going to be my second one. We have this formula, it looks like this. Now let's say I want to find the energy, and so I've got this, which I'm trying to find. My V, or my frequency, is going to be 3.8 times 10 to the negative 15. And I am trying to find the energy, but I'm going to need this number. This guy is referred to as Planck's constant. So it's a constant. So when I'm using these, it never changes. I'll allow you a second maybe to write this down. Again, the math part's rather easy on this. So let's say I want to just place this in the formula. Well, that's kind of easy because all I have to do is multiply these two numbers together. So it's going to be, basically 3.8 times 10 to the negative 15. And then you're going to multiply it by this number here. So when you have your number, it comes out here, it's going to come out as 2.52 times 10 to the negative 43. So you can kind of estimate it looking at these exponents, it's going to come out around the same sort of thing. And that should be a 48. Didn't look right. Because I was adding it, and it looked like my exponents, when I added these together, equals that. But when I run it on the calculator, and I multiply these together, it may come out a little bit different. So let's go ahead. I'm going to have to rerun this because I want to make sure this is correct. would recommend, if you're coming up with a weird looking answer, you may have to calculate it. And actually, I put in the wrong numbers. And it looks like this. That is the correct answer. Now, if you're going to just go ahead and actually, again, intimidation by this, you could multiply these two numbers together and it'll come out 25.2. The exponent would be a little bit different, but then let's just go ahead and do that. Yeah, I know what it's going to come out as. It'll come out as 25.2. That's a negative 49, but if I wanted to change it to look like this, this may be what you're thinking. Again, it's going to match a whole lot with your test, but if I move this one time to the left, it means that number is going to decrease by 1. So again, there's two ways to kind of deal with that. If I switch it around, let's say I want to find my frequency. And this is my energy. Again, my Planck's constant is 6.626 times 10 to the negative 34. Then all I have to do in this case, the one few times that you actually have to modify it, in order to solve for this one, I just have to divide my energy divided by Planck's constant would equal this. So then I just pop in the numbers. If you wanted to give that a try on your own, this will actually end up being 5.7 times 10 to the 18th power. So basically the way I have it here, you'd be dividing it. Again, you'd be flipping this one up to the top. So I'm going to know that it's going to be around times 10 to the 19th power. Your other number will look like a 0.57, but then your exponent is going to go up by 1. Again, I believe that since it's a multiple choice, all you have to do is just make it close to whatever that answer is, and as long as your numbers are matching up and your exponent is within the ballpark, then you're good. Let's go ahead and do another one. So let's say I want to do these longer, more difficult ones. They're not really that more difficult. You're just using more variables. So let's say I want to use my energy, which is 4.8 times 10 to the negative 18, and I want to figure out my wavelength. Well, you're going to notice if I'm using these two things here, and if I'm trying to use a number here and find this, it's going to be a little bit tough to go between formulas. But it is rather easy to use the formula, because instead of this guy here, you're going to have the same sort of thing you're dealing with here, except you're going to notice you got your two constants at the top, just kind of like with this one. So let's say I want to find my wavelength. Now I'm going to put my constant for this and my constant for this, and then I'm just going to pop the number that I'm finding, which is going to be 4.8 times 10 to the negative 18 at the bottom. So we're going to use the numbers 3.0 times 10 to the 8th times 6.626 Planck's constant times 10 to the negative 34. Those are taken care of now. And then you just multiply and divide. It's all the same thing, same procedure. The calculator I provided kind of helps you a whole lot as far as the calculation. I would suggest you probably give it a try on that calculator part online, and this will be kind of easy for this. I'll put the unit there. So that's what it's going to end up with like on this. Now again, if you want to look at the exponents, I would add these two together, which would be a negative 26. Then I would have to flip this one up to the top because I'm trying to kind of multiply it. When I'm dividing, take care of the negative exponent. It looks like this, and my exponent should be around a negative 8. Hopefully this kind of makes sense on this part, but if not, just practice a little bit on the calculator. Let's say I want to flip it around and actually find the energy. Well, if I do want to find the energy, then I would be changing this one out. I'm going to find the nice part about this thing. Because again, I'm using my constants. So let's say that I actually have a wavelength, which is now 7.5 times 10 to the negative 17, and let's say I'm finding my energy. Well, if I do my manipulation for my formula, you're going to notice it looks a whole lot similar to it. It's all set up the same way. If you look here, you multiply your two constants at the top again. And then you just put your other number down at the bottom, which is 7.5 times 10 to the negative 17. If you calculate this whole thing out, it should end up being 2.65 times 10 to the negative 9 for my energy. If you're again looking at the exponent part, when I add these two together, it comes out as a negative 26. I flip this thing up to the top, it becomes a positive 17, and you're going to notice my exponent's going to be a negative 9, and those match up. So what I would just say is try the calculator part. You're going to have to get your first number anyway, and you can do that little manipulation tool with the exponents, and you can still come up with pretty close to the correct exponent, but if not, you're going to be very close.